For years, the C-130 has played the part of its name, Hercules, and always in a helpful role. It is used to haul cargo, troops or passengers, and litter patients. It is an indispensable element of TAC airstrike deployment and is a launch platform for Firebee drones. It performs air rescue pickups from land or sea. And can be used as a tanker for HH-3E helicopters. It recovers capsules from Discoverer satellites, performs photo mapping missions, and tracks storms for the Weather Service. It has been used to support operations in the Antarctic and is included in the inventory of the Navy, the Coast Guard, and 13 foreign countries. Here at Wright-Patterson Air Force Base, under the management of the Deputy for Limited War, the Deputy for Flight Test changed its costume again to play a different part, the role of a night-prowling attack aircraft called Gunship II. With its electronic eyes, it seeks for and finds its own enemy targets, then smashes them with a devastating rain of firepower from 8 side-firing Gatling-type guns at a rate of 34,000 rounds per minute. But before this AC-130 prototype could be sent to Southeast Asia, months of modification and testing were required. One of these was the stuffing of fuel tanks with inerting polyurethane foam for the suppression of explosion in the event of an incendiary hit. It was very important that each piece of foam be cut to fit snugly and exactly around pipes and tubing, and into all corners and crevices to eliminate any voids where fuel could accumulate. An aluminum booth was also built for the sensor operators and for installation in the center section of the aircraft. The booth was completely insulated with about 2 inches of Celotex, and then a layer of sound-deadening acoustic tile was also applied on the inside to reduce aircraft noise about 45 decibels to provide greater operator concentration on imagery and instruments. To provide even greater safety, its floor was armor-plated. Many items of equipment were removed from the interior of the aircraft for the addition of 4 of these 20mm side-firing Gatling-type cannon on their special mounts. 2 were mounted forward and 2 aft. Mounting the cannons presented several problems. While they could be bore-sighted as to azimuth and elevation, they had to be anchored in a fixed position. These 2 at the rear posed a special problem because 2 7.62mm guns were mounted immediately above them. The forward cannons were mounted just behind the pilot's compartment. This was an easier installation because the 2 miniguns were mounted above and aft of the cannons. Nevertheless, all 8 guns had to be wired into the computerized fire control system so they could be fired in any combination or rotation the pilot wanted. Some idea of the tight fit of the rear guns is shown here as engineers closely examine the clearances that have been allowed for their operation and maintenance. The installation of the forward miniguns was comparatively simple and allowed ample room for the tubes that capture the spent shell casings and for final inspection of the installation of both the guns and their wiring. The sensor operator's booth was then installed. Several sensoring devices and other electronic equipment will be placed in it. The loose curtain around it is ballistic felt for further protection from flak. This is a better perspective of the forward 20s with miniguns above and aft of them, the aft 20s with miniguns directly over them, and the side-looking installation of a Beaumark A radar. This first radar installation proved unsatisfactory and was changed later. This view of the 2 rear 20mm cannons next to the radar shows how compact all modifications had to be. The 2 forward 20mm cannon have been installed at an extremely low angle of depression, but this was not their permanent position. A view forward shows the 7.62 miniguns mounted in their firing position. Here again, compactness of installation is demonstrated by the closeness of the forward miniguns over the wheel well, and the size of the apertures in the fuselage, which are just large enough. With all major modifications to the aircraft completed, a last walk-around check and inspection is made before takeoff for Eglin Air Force Base for first flight test and static test firing. For the flight to Eglin, the guns were stored inboard and the gun ports closed. At Eglin, the aircraft was made ready for its first static test firing of the 20mm cannons on their specially fabricated gun mounts. This was the first deficiency encountered in the mounting of the guns. They weigh 350 pounds and had to be manually worked into their cradles affixed to the base plate. A third man was needed on the inside to help and to set the gun at the desired elevation. After all 4 guns were placed, anchored, and sighted, the belts of ammunition were loaded. The aircraft normally carried 6,000 rounds of 20mm high-explosive incendiaries and fires at a rate of 2,500 rounds per minute. The first static firing showed a deficiency in the mounts that allowed the guns to whip. A close-up shows the extent of whipping that brought about a pattern of widely scattered hits. Even though all guns showed the same whipping, an airborne firing test was made to learn what the results would be. The 4 squares are the target on the pilot's fixed reticle. The rear guns fire, miss widely, and aircraft vibration is noticeable. Then the forward pair of 20mm cannons were fired. And this air-to-sea view shows how far off target they were. The second and third bursts were also wide. Then all 8 guns were used. The miniguns were closest, some being on target, but they generally hit in a widely scattered pattern. Correction of these conditions was a prerequisite, so the aircraft was flown back to Wright-Patterson for further modification and the addition of other items to make it ready as a night prowling aircraft for combat duty in Southeast Asia. The change began with the addition of camouflage in the colors used in jungle country. Apertures were cut out for the addition of several censoring devices. The tedious and intricate job of wiring all guns, communications, and electronic equipment was accomplished. The forward-looking radar on the nose was checked and inspected to ensure its accurate and efficient operation. Heavy armor plate was cut to size for addition to the aircraft's flooring sections to take and absorb direct hits from small arms ground fire and heavy flak particles. The Beaumark A radar was further modified to work with ground beacons. This makes possible firing at targets offset from ground beacons, thereby bringing all-weather support to friends on the ground. A new direct view night observation device called NOD was also installed. In effect, NOD is a nighttime telescope. With only the stars as a light source, its image intensifier tube behind the lens will magnify the available light by a factor of 1,000,000, thereby making targets clearly visible. Another of the gunship's electronic eyes that was installed is this side-looking infrared system. The mirrors in the scanner head spin at about 7,900 RPMs and are part of the system that detects minute differences in temperature, as little as 1/2 degree centigrade, and turns these temperature differences into visible pictures, even in total darkness. An onboard illuminator is another important element used to search for and find targets at night. Its 20-kilowatt xenon lamp produces 700,000 lumens and can illuminate targets a mile away, and its infrared filter can be used covertly for illumination when it is too dark for NOD to see. The illuminator is used on the aft end of the aircraft, about 4 feet beyond the ramp. It can be pointed fore and aft of the aircraft, and also from side to side. After serving its purpose outboard, It can be swung inboard on its swivel joint and stored out of the way for future use when needed. The aircraft was also equipped with a newly designed UHF radio beacon system that allows the pilot of the aircraft to read direction and slant range to a ground-operated transceiver. And so the venerable C-130, which has been worked over, facelifted, officially designated as an AC-130 and Gunship II, has Vulcan Special painted on its side, and is affectionately called Big Spooky, takes off once more for Eglin and in-flight testing. At Eglin, it is taxied into position for static test firing before airborne testing of guns and electronics. All guns have been set, loaded, and made ready for the first test of the stiffened gun mounts and beefed-up base plates. The pilot checks to be sure everything is clear, then fires. First the rear, then the front. The gun whip problem has been solved, and the guns hold steady. Then all guns go. There is still no whipping, and the pattern is effectively clustered. The guns were then aimed at nearby targets, and another burst was fired. Both targets were destroyed. Big Spooky was now ready for in-flight testing. First flight testing at Eglin was done by VFR to test each piece of sensor equipment and its input to the computerized fire control system, and also to test the synchronization of the guns with the same system and sensor equipment. Now let's watch each operator using his sensor. The nod operator scans for the target, finds it, and makes the information known so it can be fed to the fire control computer. The computer operator sets in the flight wind correction necessary for firing accuracy, and the infrared operator scans with his sensor until he too is bearing on the target. A stick control is used to direct the infrared scanner head in a search for the target. When it is found, the information automatically goes to the computer. The fire control computer gives the pilot guidance, and he flies his aircraft and maneuvers it until the needles are centered. When they are centered, he knows he's a beam of the target. The pilot then rolls the aircraft into a 30-degree bank, orders the guns he wants from the master gunner, then transfers his attention to the fixed reticle. He maneuvers to superimpose the computer-generated moving reticle over the fixed reticle to pinpoint the target. When pinpointed, he presses a button on the control column, and the guns he has ordered shoot. The cannons, the sensors, the computerized fire control, and the pilot's side window gun sight all prove out, as the target is smothered, even though it is a mile away. Then the miniguns go, followed by the 20mm cannons. The orange bursts are direct incendiary hits on a target only 24 feet square. Other night mission equipment was also tested, including these Mark 24 flares in an LAU-74A launcher. The flares fall to preset altitudes, then pop open, producing about 30 million candle power of illumination as they float slowly down. In the event of a hit on the quick jettison launcher, the smoke-clearing capability of the aircraft was tested with a smoke pot on the ramp. Smoke clearing was rapid and complete. The pilot calls for the xenon lamp to illuminate the target for night test firing. The black cone in the center is on target. All 8 guns were used, and all were on target. The guns, the sensors, and the computerized fire control all proved to be satisfactory for combat. With the result, the prototype AC-130 was deployed to Southeast Asia on 15 September, where it flew more than 70 combat missions in Vietnam and Laos. In December, it was brought back for rework, and then redeployed to Vietnam in February. Primarily, its missions were night attacks, and the same procedures used successfully at Eglin Air Force Base were employed. Normally, Big Spooky carried 6,000 rounds of 20 millimeter and 32,000 rounds of 7.62 ammunition. Over the Ho Chi Minh Trail, it was shooting nearly 8 tons of ammunition per night. In just 1 week of night interdiction missions in Laos, Big Spooky proved the devastating effect of its accurate and smothering firepower. On 7 sorties along the Ho Chi Minh Trail, the enemy's main avenue of supply and communications, it destroyed 23 trucks, damaged 8 more, set off 22 secondary fires and explosions, and knocked out 3 automatic weapons positions. The AC-130 has clearly demonstrated under combat conditions that a new dimension has been reached in night attack operational capability, and its impact is sure to be felt in future Air Force systems and tactics.
The Ho Chi Minh Trail, the enemy's lifeline to the war in South Vietnam and Cambodia, is an intricate and complex road system. Thousands of trucks racing and plunging along this maze of trails carry the materials of war. Materials of war that enabled the Viet Cong and North Vietnamese to terrorize and attack our allies and our own ground forces. Believe it, the trucks are there, but they're not easy to find. An enemy truck convoy can always divert from one road system to another, hide under the tiered canopies of tropical forests, park and refuel under camouflage, and because of our daytime tactical airstrikes, they always run under the cover of night. The only way to stop this flow of war supplies is to search out the trucks in the night, acquire them as targets, and destroy them with powerful and accurate gunfire. For this mission, the Aeronautical Systems Division has developed for tactical employment a remarkably successful weapon system for the Air Force, the AC-130 side-firing aircraft. Flying a small percentage of the interdiction sorties over the trails, the aircraft in this program have accounted for an impressive number of all enemy trucks destroyed or damaged. Night armed reconnaissance is the primary mission of these aircraft, but they're highly versatile. They're also effective in other night combat operations, such as interdiction strikes deep in enemy territory, close air support of troops, escort of ground convoys of friendly trains, trucks, and river ships. And because of their ability to locate and orbit a target and to see in the dark, they're frequently used as forward air controllers for fighter strikes. However sophisticated the weapon system is, it is only as effective as the combat crew who flies it. 14 of you acting as one. The great majority of your missions will be flown in darkness, and every one of you in the crew contributes to the accuracy of every shot as well as to the safety of every mission. Now, the whole trick in being a successful AC-130 combat team is to understand the basic geometry of the firing orbit, develop your skills in operating the sophisticated sensors, fire control system, and weapons, and to coordinate with one another in split-second timing. For all side-firing aircraft, AC-47s, the AC-119s, or the AC-130s, the basic firing geometry is the same. The aircraft flies a left-turn orbit in a 30-degree bank at a constant altitude with the specified true airspeed around an aim point. Now, this geometry establishes a definite slant range to the aim point that's superimposed over the target. For each different attack altitude, your guns are readjusted and fixed so that your fire will hit the aim point. For each attack altitude, a different sight line. Therefore, a different gun depression angle. Now, a sight line is a straight line, but of course, the ballistic path is not. there's a ballistic drop here that must be compensated for in the gun settings. Now, these settings are obtained by bore sighting on the ground. But when you're airborne, each gun must be fired to check the accuracy of these settings. It is this sight and gun angle adjustment that enables the aircraft to fly its 30-degree angle of bank for all attack altitudes. Now notice that regardless of the attack altitude, the radius of the pylon turn will be nearly constant. The attack altitude and the true airspeed must be selected before entering the firing orbit. To compensate for the forward velocity of the aircraft, the guns are adjusted to fire slightly aft of the sight line. Now, this angle is called the gun lag angle. Obviously, as airspeed increases, the gun lag angle must be increased. Now, with your sight line directly on the target, your guns are aimed at a point might be about here. This compensates for the forward carry of the aircraft and for the ballistic drop. This simple firing geometry enables the pilot to zero in on his target throughout a prolonged attack, keeping the target under constant surveillance from 360 degrees. Of course, there's always something to complicate a basic theory: wind. Wind not only affects aircraft position and travel, it also displaces the impact point of the ordnance. Now, the pilot will maneuver the aircraft to compensate for wind drift. He will increase his angle of bank on the downwind arc of the firing orbit. He will decrease it on the upwind arc. Now, as you can see, a 30-degree angle of bank can be maintained in these areas of the firing orbit. And it's from these arcs that he will usually fire. The aim point for firing will be offset into the wind, just as you offset for wind on the rifle range. Now, if your shots consistently group off target, that indicates an error caused by wind. Of course, on board a weapon system as sophisticated as the AC-130 side-firing aircraft, you have a computer that's quite capable of compensating for wind drift. Now, how do you crew members and your weapon system fit into this geometry? Let's start with the gunners. But first I better explain that the pictures we're going to show you are not of the photographic quality of the film you're looking at right now, but the training and combat photography and the battle damage assessment footage will give you an idea of what you will actually see, how the fight really goes. So now let's get with those gunners. On the other side of the bulkhead, behind and below the pilot, is the forward gun station. These first two guns are 20mm Vulcan cannon with a rate of fire of 2,500 rounds per minute. They're manned by two forward gunners, and when these cannon are fired, you two men will be busy loading and manning. The third and fourth guns are the miniguns, 7.62mm. They have a rate of fire of 3,000 or 6,000 rounds a minute. They're used for strafing in special situations, such as support of friendly troops in contact with the enemy. They're manned as needed by one gunner from the forward or aft gun crews. In addition, one of the gunners must man the right forward scanner position. The fifth and sixth guns, the 40mm, are the truck killers. And they're as accurate as sporting rifles. The long reach of these guns gives you a greater slant range. That means greater standoff distance, which greatly reduces your vulnerability to the enemy's anti-aircraft artillery, AAA. The gunners who man the 40s will be spelled and helped by the two forward gunners. In hostile areas, that AAA has a bad habit of coming up at you. Every man in the crew who can see it watches for it. But one crew member is a specialist. He's the illuminator operator. and his position in the aircraft is unusual to say the least. He lies prone on the open ramp in the rear and watches below for AAA. If it's coming directly at you, he calls it accurate, and the pilot takes evasive action. If the AAA angles away from you, he calls it inaccurate, and the pilot continues in the firing orbit. While he plays this tricky game, he drops ground markers. When they light up on the ground, a fighter strike can be called in against the AAA gun bunkers. If you have what it takes to be in this crew position, you'll also operate the 40 kW illuminator and the flare launcher when they're installed. The sensor operator's booth, located on the right in the center area of the cargo compartment, is acoustically treated to keep out the bang and roar of the guns. It's air-conditioned, protected by steel armor, and covered with ballistic repellent material. There are 3 officers who operate the sophisticated sensors, and a fire control officer who coordinates sensor operations. The electronic warfare officer operates several sensors. For example, Black Crow, a specialized electronic sensor, and the beacon tracking radar. Using the Black Crow sensor, he will usually be the first one to detect a truck moving along a trail. That radar is used principally to locate a friendly troop position where a transponder beacon is located on the ground. In bad weather, which is when the enemy is likely to attack, this can be of the greatest importance to ground forces. In such a situation, fire support is directed against the enemy an offset distance away from the friendlies. This officer also operates the Trim 7 and other advanced electronic countermeasure systems, the infrared reconnaissance system, the low light level television, and the 2 officers who operate them are the real night eyes of the AC-130 weapon system. The infrared sensor, the IR, is an extremely precise heat sensor. So sensitive, it can detect minute temperature differences and show it in real-time imagery, much like black and white television. Target images are magnified by a factor of 4, and the aiming reticles are etched into the display. If you're the IR operator, you will learn there are many tricks in operating this sensor, and it's your job to know them all. You can see through haze when the TV cannot. You can search the roads beneath with a wide-range picture. You can change scale for a close-up look. You can select white-hot or cold-hot polarity depending on which mode shows the target best. Jungles are cool, roads are warm, and running truck engines are hot. There are lots of questions, but you don't have to answer all of them by yourself. You're part of a team, and you can always cross-check with the TV operator. Either one of you can slave his picture to the other fellows. Television needs only moonlight or starlight to present you with a picture of the Earth below. The 2 kW illuminator is slaved to the TV to brighten the image on a dark night. That illuminator, a xenon arc lamp of extreme intensity, can be operated in either a visible white light mode or in an invisible IR spectrum. It is always operated in the IR mode while in combat, so that it is not visible to the enemy below. A distinct advantage to the operator of the TV is its narrow field of view that enlarges the target by a factor of 6. Every man in the crew who is acquiring or tracking a target is measuring the aim point in terms of mils. Everybody's talking the same language, but that's still a fine sighting to make from a moving aircraft. If you're sighting and firing along a 12,000-foot slant range, 1 mil of tracking error, and you miss the target by 12 feet. For the IR and TV operators, that means stay steady. Track your target slowly and evenly, and lead a moving target by about 2 lengths for every estimated 10 miles per hour of the truck's travel. If it's a truck convoy, destroy the lead truck first. That jams up the convoy.
You see in the open or something like that?
In the open, roger.
You're cleared. Here, we got Paul with us. Picked up by
Yes. Okay, just sped up considerably.
He is a mover and he has got his lights on. We're gonna need him.
He's slowed down considerably, but he's still moving. There's another one up the road. TVM.
Okay.
Okay, down 300 feet.
That's all right, that's right.
Let's take the lead one, Charlie.
Roger that.
Okay.
Oh,
look at that. We got dozens.
I don't know. Gun.
Going after the lead.
You can't go down 300 feet. I want a gun.
You got one.
Trying to stop him. 125. 4.
Stop.
6 trucks.
Okay, Boyle, we're all right. Stop. Let's get it on.
Okay.
Hit on.
Go.
Hit on number 2. Hit on number.
I can't say it, boy. Breaking out.
Hey, what kind of airspeed you want done now?
Anything. Roger, give me base, gunners. Sarah, one just flew up.
Roger.
Yep, the truck that was on fire blew up.
You come up to 10605.
And Paul, we're going to move down the road as far as block this up. We're moving down to truck number 5.
What are we doing that for?
We cannot see the other truck.
Okay. Sorry, he just blew up again.
And that fire is big enough to blow all the trucks on the curve. In fact, the block of mine truck out now.
Rod, we just got 4 trucks.
Oh, beautiful.
Yeah, I think we got them all.
Oh, rip. Uh-oh. Get out of here. Let's break right. Keep your head in. Keep your head in. Keep your head in. Don't. Underneath. Don't let me go in here. Turn around. Keep on this. 6 o'clock. 10 more rounds. 3 o'clock. Keep on the 6. Keep on the 6. Hold on.
There's one other sensor switch that's particularly important. The consent switch on the operator control panel. When you depress the consent switch, you give the pilot a light signal that tells him you're on the target. The firing circuit is interrupted when the switch is redepressed and the pilot cannot fire in the automatic mode. What happens to all this target information you fellows are picking up with your sensors? It goes into the very heart of the weapon system, the fire control computer. The fire control officer determines which sensor has the best picture of the target. He computes and gives data corrections to the navigator when shots miss the target. In the AC-130A models, the analog fire control system on the flight deck displays the target information for the navigator. The navigator keeps the computer continuously updated with modifying information such as wind direction and velocity, corrections in azimuth and elevation, heading and slant range, true airspeed, coincidence, and target offset. This is the information that is passed to the pilot. It is registered continuously on his steering indicator and in his optical gun sight. Guided by this computerized information, he flies the aircraft into the attack orbit. That's when he turns into his side-mounted optical gun sight, and as he does so, he calls for armed guns. The flight engineer arms the gun that has been selected and that is on the line. In the gun sight, the pilot refines his aim by maneuvering the aircraft so that the fixed and movable reticles are superimposed. The navigator confirms that the target is clear of friendlies, and he coordinates the clearance to fire. The sensor operator is tracking the target. The consent light is on, and the pilot triggers off the shot.
Direct hit on one of the trucks.
10 o'clock, no sweat.
No sweat.
Turn around.
Okay, we're, direct hit on the same truck. Squads look like it's drifting away from the water there. Or from the shore.
No, not.
Let's get right in them.
None of it has. It has drifted very far off.
Direct hit. So we have a fire on the barge.
Oh, up to the middle, huh?
Roger that.
Okay, that's target 4. Boat number 1.
You got balls. Let me see that, Willis. Ship.
Destroyed, it's burned.
It's a ship. Ship of the line. 16-inch guns. Co-pilot now. We're on the 307 for 78 off of 94.
He's got us.
Oh, it's there. 5-6-5. Group was good, started out 2-5.
Oh, shit. Okay, hold it down. That's going to knock out the rest of the truck. Let's get to him.
They got on IR. Holy mackerel.
We got us something tonight. Okay. Let's knock off the top and get the rest of the truck. Okay, crew, what do we have?
Okay, we just hit truck. We had the biggest explosion I've ever
one
seen.
big blower. Let's get off and get the rest of the trucks.
Roger that. Stay off here. They're getting shot at. Give me the next one.
Okay.
We've been looking at aircraft in what we call the Pave Pronto configuration. And there's a great deal more about this weapon system than we've been able to tell you. There's additional equipment, like the laser target designator. There's tricks of the trade you can learn only by flying the system. And there's additional equipment on board that further illustrates the degree of sophistication reached by this weapon system. These AC-130 side-firing aircraft in the Pave Pronto configuration have really proven themselves far beyond expectations. Now, in the follow-up AC-130E program, one that we call Pave Spectre, the weapon system is even more advanced. A new additional hydraulic system, very extensive armor plating have been installed to protect you and your equipment. An advanced digital computer provides increased flexibility to the fire control system. This enables the pilot to fire accurately even though he's not on nominal bank, altitude, or true airspeed for the selected attack orbit. If your shots miss the target, the fire control officer simply clicks in the miss distance and direction. Whatever's caused the error, wind, gun setting, sensor alignment, or aircraft skid, the computer computes the proper azimuth and elevation corrections, and that next shot should be on target. Besides the digital computer, the aircraft in the Pave Spectre program are equipped with a heads-up display that gives the fire control officer and the pilot additional information and greater accuracy for every shot. This is a sophisticated weapon system operated by a skilled crew. The co-pilot monitors airspeed and altitude, and he makes what flight adjustments are required of him. He's also the man who's coordinating with the gunship's fighter escort. Besides his job of precision navigation, the navigator is in contact with the airborne command post, and he coordinates the clearance to fire. He plots friendly positions and keeps the battle log. Along with coordinating and selecting the tracking sensor, the fire control officer is responsible for pinpoint corrections in the fire control system, and he advises the pilot. He operates the battle damage assessment recorder and calls the results of all firing to the crew. He also records additional information for subsequent attacks and for post-mission analysis. Beyond his usual engineering chores, the flight engineer coordinates with the gunners on a private intercom, and he arms the guns selected to fire. The gunners must keep ahead of the guns, keep them constantly loaded, ready, and on the line. One gun jams, and instantly they have another on the line. Their guns are always ready for the next shot at the next target. a target the sensor operators are constantly searching for, acquiring, and tracking. And let's not forget that scanner, that illuminator operator, lying out there on the open ramp, calling and marking enemy anti-aircraft artillery. All this is going on at the same time. 14 men linked together by 3 separate intercom systems, acting together as one team. The AC-130 side-firing aircraft, developed for the Tactical Air Command, are becoming constantly more sophisticated.
105 howitzer on the line.
But the greatest thing about the AC-130 side-firing aircraft will always be the combat crews who fly them. There's no substitute for skill and guts.
Yep. Big one.
TV's back.
That's a big gas truck.
TV's and fighter truck.
Go.
Crash is underneath.
Okay, you gotta climb now.
Okay, we're going up.
And I still don't have secure on 2. Pilot, 2 drivers got out and are running to the rear. 3 drivers.
Affirmative, TV had them also. They're calling you. There goes the truck again.
He's moving
again.
Fire.
Slow it down. Oh, he's moving into the woods. Oh, that one, they're way behind me now. Level off.
No, wait a minute. They jumped it off the road. It's falling down.
Yeah, they jumped it.
The thing rolled off the cliff.
There it goes. There it goes, TV's. All right, we don't have to shoot it then. We'll just nail it in a minute. Just exploded. Negative. No, it's gonna shoot her. You want to go up? Yeah, just keep her coming up. Okay, we in good shape now.
A new model troop and cargo plane was completed and put under flight testing for the U.S. Air Force in 1955. It was the C-130 Hercules, a medium-weight prop jet transport built by the Georgia Division of Lockheed Aircraft Corporation to speed men, cargo, and equipment to America's defense outposts. Construction of this aircraft was well underway when the year 1955 began. 6 production model C-130s were already under construction in January. At that time, the first plane, serial number 3001, occupied position 2 on the production line. The aircraft soon was moved to the final assembly position. A check was made to see that the actual weight of the engine, an Allison T-56, met specifications before installing it on the plane. In the meantime, Curtiss-Wright propellers were uncrated, reversible blades were fitted into the hubs, and operation of the blade change mechanism was checked. A preservative was added to the engine fuel system until actual engine runs could be accomplished on the flight lines. The engines were turned by air-ground power for the pickling process. All engines were installed by mid-February. Before the plane left the production line, installations of personnel seats and equipment were checked and found to be satisfactory. The seats were removed, and special first flight test equipment was installed. The first aircraft was then moved to the Engineering Flight Test Department for flutter and vibration tests. By late March, fueling operations and tests had been completed on all engines. High-speed taxi runs were made to check the operation of different systems and equipment preparatory to flight. The first production C-130 took off on its maiden flight on April 7, 1955. Only about 800 feet of runway were required for the takeoff. The plane was in the air 1 hour and 7 minutes. During this flight, landing gear and stall tests were satisfactory. Starting with this trip, a half-dozen C-130s logged a total of 94 hours and 17 minutes in tests during the remainder of the year. The landing on the first flight was routine. Using reversible propellers, the plane required only about 2,000 feet of runway for the landing. On a landing a few days later, however, a fire developed resulting from the failure of a fuel quick disconnect behind engine number 2 firewall. After the aircraft was repaired, more test flights were conducted. While number 3001 went through production, pre-flight, and engineering flight testing, static tests were being performed on airplane number 3002. The second aircraft had been designated as a static test article, a guinea pig for experimental purposes in the C-130 program. The fuselage of the static test article was prepared for an air pressure test. It was filled with containers to protect against serious damage should the section fail. The aft section failed at 12.74 pounds per square inch. To reduce potential damage resulting from pressure tests, Lockheed proposed that further tests be conducted hydrostatically. The Air Force concurred. A concrete pool was built for the hydrostatic or underwater tests of the aft and nose sections. The pool cost approximately $20,000, and the water method has saved an estimated $500,000. The water testing procedure was simple. The fuselage section was bulkheaded, made watertight, filled with water, and submerged. The interior was pressurized. With the conventional air pressure test method, when failure occurs, the force of the exploding compressed air causes secondary damage, which sometimes makes it difficult to find the origin of the weakness. Damage to the section is less in the hydrostatic test, since water, for all practical purposes, is not compressible. The forward section was pressurized satisfactorily. The aft section, which failed in the air pressure tests, was replaced and submerged in the pool. The section was successfully pressurized to 15.1 pounds per square inch, more than twice the normal operating pressure. Due to the uniformity of the center fuselage section, and as a result of some previous testing at the California Division, it was considered safe to test this section with air. The section was pressurized to the required 15 pounds per square inch. The outer wing flaps were subjected to extensive fatigue tests. As weaknesses were observed, designs were improved until the flaps successfully completed 8,000 cycles. When tests began on wing down bending, it was necessary to use stop-motion photography to speed up the slow bending of the wing. The jumpy movements of the workers were caused by this camera technique. The slowly bending wing withstood ultimate load for 3 minutes without failure in the test for dynamic taxi, a condition critical for the outer wing panel. It also withstood ultimate load during the test on wing down bending and main gear load, a condition critical for the wing and main gear combination. A number of other tests were performed in an effort to improve the design of the C-130. Among these were the lateral gusts on the aft fuselage, including simulated airdrop, that is, with the cargo door open. The J2 door test, the tail-down springback test, and the test on the cam followers on the flaps. When the examinations disclosed any weaknesses, improvements were made until the parts were satisfactory. Separate tests were conducted on many vital parts of the C-130. For instance, the hydraulic reservoir was filled to capacity with fluid and slashed and vibrated simultaneously for 25 hours, simulating the most severe operating conditions. There was no leakage. During the year, special tests were made on a new cargo floor design. The new floor was constructed of extruded stiffeners riveted to a metal skin, which could be used to replace the solid machined stiffened panels in event of need for wartime acceleration of the C-130 program. The rolling test consisted of a rubber tire under a load of 6,500 pounds, rolling back and forth across the floor 2,000 times. Operation of the main landing gear was observed under extreme temperature and environmental conditions and was also subjected to sand, frozen mud, and salt spray. Temperatures range from -65 to +160 degrees Fahrenheit. This tandem landing gear is designed to enable the plane to operate safely from semi-prepared landing fields. While the static test article was undergoing many rigorous qualification tests, other C-130s completed production airplanes were used for flight tests, demonstrations, and briefings for key military personnel. The first show was staged in July. Military personnel, newspaper reporters, photographers, and top television and radio people from all over the nation came to Marietta to see the new air freighter. The demonstration began with an exhibition of the flying characteristics of the Hercules. The turboprop C-130 is the fastest transport plane in production for the U.S. Air Force. It can travel at speeds of more than 370 miles per hour. A fast climbing aircraft, the C-130 can reach an altitude of 2,500 feet in only 60 seconds. A versatile plane, the C-130 can fly with the Stratojets at 40,000 feet altitude on long missions, or it can dip low enough to drop paratroops and supplies to advance military base operations. The reporters, television, and radio men watched the Hercules back up over great distances. The unique ability to travel such distances in reverse makes the plane particularly useful in combat zones where time and space are limiting factors. The steerable nose wheel and the reversible propellers allow the aircraft to park in a very limited area. The riders and military personnel saw a display of the loading capabilities of the cargo transport. Men from the 18th Air Force, Donaldson Air Base, South Carolina, staged the demonstration. A 5,000-gallon jet fuel tanker was driven into the aircraft using the built-in loading ramp which serves as a rear door. This ramp also can be put at truck floor level for straight-in loading. The plane can accommodate 20 tons of heavy equipment. The changeover from cargo to personnel transport can be accomplished in a matter of minutes. 92 troops marched into the airplane during the demonstration. The C-130 can make either aerial or ground deliveries of men and cargo. In November, the C-130 presented a demonstration of loading general cargo at Dover, Delaware for the Military Air Transport Service. A training program was inaugurated to prepare men to become crew members of this prop jet plane. Spare parts shipments to the Air Force commands, which are to receive the C-130s, were ahead of schedule. The Air Force decided to change from Curtiss-Wright propellers to Aero Products propellers. Aero props were installed on engine number 3 of the 6th airplane, and tests were begun late in the year. The cargo transport is to be used as a supply ship in the Arctic regions. Development design was started on a ski wheel for the C-130. The ski wheels were scheduled to be flight tested late in 1956. In preparation for flights into snowlands, the tail of the C-130 was painted red, the standard Arctic marking. The color makes the aircraft visible against a background of snow-covered or even desert terrain. The testing and production programs were on schedule at the end of the year. 12 C-130s had been completed. Some were released to the Air Force for testing. Airplane number 3018 was starting on production line. Climatic, aerial delivery, desert, wind tunnel, and Arctic tests were scheduled for the next year. A highlight of the year came when the Hercules made its first extended flight, flying from Marietta to Philadelphia for the National Air Show. By late 1956, the new versatile cargo transport was scheduled to take its place as an operational unit of the United States Air Force.
If you enjoyed this video, please remember to like and subscribe. And as always, thank you for watching.